Okay, let's take a few moments to discuss the basic idea of what we call a reflection. And this is a type of transformation that is generally not one of the more complicated ones to understand. As long as you get the overall concept, you can pretty much apply it to any situation. So I put this point A out there, and I didn't put a location with it. I didn't put the coordinates because I want you to just think conceptually. This could represent any point. But if I find this point A, and I was asked to reflect it about the x-axis, so sometimes you'll be asked to do something like this: reflect about or across the x-axis. And what does that really mean? Well, what that's telling me is the x-axis is essentially like my mirror. Okay, and if I were standing at point A and I was looking into this mirror, and let's just say I was, I don't know, 4 units away from that mirror, well, I would see my reflection the same distance away looking back at me on the other side. So we would call this A prime. That is the reflection. So it's just like we're looking across this mirror, and it's going to be the same distance away on the other side looking back at us. Okay, so this point right here is the reflection of point A across the x-axis. Now how could this look different? Well, if we were asked to go across the y-axis instead, we got to look to see where that is, and the y-axis is over here. So I would take point A and look and go, oh, you know what, I'm 2 units away from the y-axis here, so if I was looking into the mirror this way, I would see my reflection sitting right over here, looking back at me this way. So that location would be the reflection across the y-axis. Okay, now the ones that generally bother people the most are when we aren't asked to reflect it across an axis at all. Okay, what if we were asked to reflect it across an arbitrary line? So if you were asked to reflect it across the line y equals x, now the first thing you got to make sure you know is your basic algebra. That's the same as y equals 1x plus 0. That's a line that starts at the origin, and then it goes up 1 over 1, up 1 over 1, and so on. So you end up with this diagonal line that goes like this. Okay? Now, it may not be shown on the graph when you first get the problem, but that line could still be put there. If this purple line was my mirror, well, now I pretend I'm sitting at point A and I'm looking straight into that mirror. So I'd be looking that direction, and my reflection would be looking back at me right about here. So that's the basic idea of reflections. The only way this could get worse is if you had a triangle or a square or rectangle or some sort of other shape. But all you really need to do is find one point on there, just like we found point A, one point on that shape, and figure out where its reflection is, and then you go to another point.